Hello everyone, and welcome to Grade 6, Module 4, Lesson 11, Factoring Expressions. Student outcomes for today. Students model and write equivalent expressions using the distributive property. They move from an expanded form to a factored form of an expression. Example number 1. Use the model to answer the following questions. How many 5s are in this model? 1, 2. There are 2 5s in this model. How many 3s are in this model? 1, 2. There are 2 3s in this model. What does the expression represent in words? Well, it represents the sum of 2 groups of 5 and 2 groups of 3. What expression could we write to represent this model? 2 times 5 plus 2 times 3. Let's go on to our second model. And by the way, the one in your book is wrong, so you'll have to pause the video, take a moment, and redraw the new model just to the right of the one in your book. Let's begin. Use the new model and the previous model to answer the next set of questions. How many 5s are in this model? 1, 2. There are 2 5s in this model. How many 3s are in this model? 1, 2. There are 2 3s in this model. What does the expression represent in words? It represents 2 groups of the sum of 5 and 3. What expression could we write to represent this model? We could write 5 plus 3 plus 5 plus 3. Or better yet, we could put 2 times the sum of 5 plus 3, because we have 2 groups of 5 plus 3. Is the model in Part A equivalent to the model in Part B? Yes, because both expressions have 2 5s and 2 3s. Therefore, 2 times 5 plus 2 times 3 is equal to 2 times the sum of 5 plus 3. What relationship do we see happening on either side of the equal sign? On the left-hand side, 2 is being multiplied times 5 and then times 3 before adding their products together. On the right-hand side, 5 and 3 are added first and then multiplied. In 5th grade and in Module 2 of this year, you have used similar reasoning to solve problems. What is the name of the property that is used to say 2 times the sum of 5 plus 3 is the same as 2 times 5 plus 2 times 3? Did you remember the name of the property? The property is the distributive property. Example number 2. Now we will take a look at an example with some variables. What does the model represent in words? Well, the model represents A plus B plus B, or 2 A's plus 2 B's, or 2 times A plus 2 times B. So what does 2A mean? 2A means that there are 2 A's, or we can think of it as 2 times A. And how many A's are in this model? 1, 2. There are 2 A's in this model. How many B's are in this model? 1, 2. There are 2 B's in this model. Now take a look at this model. What expression could we write to represent the model? 2A plus 2B. How many A's are in the expression? 2 A's. How many B's are in the expression? 2 B's. So what expression could we write to represent the model? We could write A plus B plus A plus B, or better yet, we could put 2 times the sum of A plus B. So are the 2 expressions equivalent? Yes. Again, we can say that, and I'll put it at the top here, 2A plus 2B is equal to 2 times the sum of A plus B. And we know that's true because each expression has 2 A's and 2 B's. Sorry about that. Example 3. Use GCF and the distributive property to rewrite equivalent expressions. So here we have 3F plus 3G equals. So what is the question asking us to do? We need to rewrite the expression as an equivalent expression in factored form, which means the expression is written as the product of factors. The number on the outside of the parentheses will be the GCF. How would problem 1 look in expanded form? 3 times F plus 3 times G. What is the GCF in problem 1? Well, the greatest common factor here is 3. So we'll put the 3 as our GCF, and we can place that on the outside of the parentheses. And how can we use the GCF to write this? 3 times F plus G. Let's take a look at our next problem. 6x plus 9y. What is the question asking us to do? Again, we need to rewrite the expression as an equivalent expression in factored form, which means the expression is written as a product of factors. The number outside of the parentheses will be the GCF. So how would problem 2 look in expanded form? Well, here's a partial expansion. 6 times x plus 9 times y. But we also need to further factor out our 6 and our 9. So we have 2 times 3 times x plus 3 times 3 times y equals. So what is the GCF in problem 2? Well, the greatest common factor in this case is 3. How can we use the GCF to rewrite this? I will factor out 3 from both terms and place it in front of the parentheses. I will place what is left in terms inside the parentheses. So my 3 will go on the outside, and I have 2x plus 3y. 3y. On to the next problem. Number 3. 3c plus 11c. Is there a greatest common factor in problem 3? So let's expand it first. 3 times c plus 11 times c. So is there a common factor? The answer is yes. The common factor in this case is c. C times the sum of 3 plus 11. Number 4, 24b plus 8. So how can we use the GCF and the distributive property to rewrite the expression in problem 4? First, let's expand each term. 24 would be 2 times 2 times 2 times 3 times b, and the 8 expanded would be 2 times 2 times 2. So now that I've expanded both terms, I'm going to see what they have in common on both sides. So I see there's 2 times 2 times 2, and 2 times 2 times 2, which of course is 8. So 8 is the common factor for both terms. So because 8 is the GCF, 8 will go on the outside of the parentheses, and everything that's left will go inside the parentheses. 3b plus, we actually have to put a 1 here. And the reason why we put a 1, because when we factored out 8, there's technically a 1 left behind. So how is this related to the first two examples? Well, in the first two examples, we saw that we could rewrite the expressions by thinking about groups. We can either think of 24b plus 8 as 8 groups of 3b and 8 groups of 1, or as 8 groups of the sum of 3b plus 1. This shows that 8 times 3b plus 8 times 1 is equal to 8 times the sum of 3b plus 1. And that's all the same as 24b plus 8. Now on to our exercises. Directions. Apply the distributive property to write equivalent expressions. So there are several of them. There's letters A through H. And what I'm going to have you do is try to apply the distributive property to each one by pausing the video and then come back and see how you did. So letter A, the common factor here is 7. So I'll put 7 on the outside, and I'll put x plus y on the inside. Letter B. And I'm not going to factor out each and every one, but I will for this one, just so you can see how it's done. So the factors of 15 are 3 times 5 times g plus 2 times 2 times 5 times h. So the common factors for this one are 5. So I would have 5 on the outside of my parentheses times 3g, because that's what's left over, plus, and this would be an h here, 2 times 2 is 4, 4h. Because again, I could have left it this way, but we always try to write it in the fewest number of symbols possible. Letter C. So what number goes into both 18 and 42? The biggest number. And if you're really good with multiplying and common factors, again, you won't have to factor out each one of these. You probably know that the number is 6. So we can put 6 on the outside. 6 goes into 18 3 times. So we have 3m. 6 goes into 42 7 times. So we have 7n. And our final answer is 6 times the sum of 3m plus 7n. Now, if that's still a little bit too tough for you, you can go ahead and factor out this. Let's see, what would it be? 2 times 3 times 3 times m plus 2 times 3 times 7 times n. So again, when looking for what they have in common, the GCF, we see 2 and 3 here, 2 and 3 here. That's where we get that 6, and what was left behind, the 3m plus the 7n. So either way, some of you can probably start factoring it out this way. And if you have to break it down into expanded form first, that works as well. Letter D, 30a plus 39b. So I know the largest common factor of both numbers is 3. 3 goes into 30 10 times, so I have 10a. 3 goes into 39 13 times, so I have 13b. Letter E, a little bit different here. You might remember this from earlier in the lesson. We have 11 times f plus 15 times f. And although there's no great GCF for 11 and 15, we can see that f is the GCF from both sides of the equation, or the expression rather. So we'll put f on the outside and put 11 plus 15 in parentheses. Letter F, we have 18h plus 13h. So same thing here. We have h on the outside, 18 plus 13. Okay? Letter G, 55m plus 11. So we're looking for the GCF. 11 is the biggest number that goes into both. 5m plus 1. Good. And letter H, 7 plus 56y. 7 is the GCF. 1 plus 8y. And when we start to go in the reverse direction, which we'll be doing some of that, you just take this outside term, this outside number, and multiply it by each one. So for example, if I wanted to expand it back to where it was, I do 7 times 1 is 7 plus 7 times 8y, which is 56y. Number 2, exercise number 2, evaluate each of the expressions below. So I'm going to, again, like in exercise number 1, see if you can solve these on your own by pausing the video. I know sometimes I move a little quickly, but go ahead, pause the video, solve letters A and B, I believe there's one more, and C, and then come back when you're ready, and then we'll complete the rest of number 2. Alright, so the easiest thing you can do here is take your time and put 3 in for the X and 4 in for the Y. I might as well do it on this side as well. 2 times 3 plus 7 times 4. And then I can go ahead and solve. So on this side I have 18 plus 44. Sorry about that. I had to pause the video. I just realized you guys have 21. I had 11, so I needed to make a correction there. So back to where we were, I was substituting the 3 and the 4 in for both x and y, and now I'm starting to solve. So 6 times 3 is 18. That part didn't change. And then 21 times 4 is 84. And I add those terms together, and I get 102. On this side, follow my order of operations. I have 6 plus 28 on the inside. Then I'm going to have to add those two together. 6 plus 28 is 32. And then 3 times 32 is 102. Part B. 5g plus 7g and g times the sum of 5 plus 7. So again, we'll go ahead and substitute our number in for our variables. So we have 5 times 6 plus 7 times 6. On this side we have 6 times the sum of 5 and 7. So we have 30 plus 42. And when you add those together, you get 72. On this side, I have 6 times 12. And of course, 6 times 12 is 72. Letter C, x equals 10. So again, we'll substitute these in. On our left-hand side here, we have 14 times 10 is 140. Bring down my 2. 140 plus 2 is 142. On this side, I have 70 plus 1. And 142. So before we get on to our closing, let's tackle letter D. Explain any patterns that you notice in parts A through C. So when we look at these three problems, A, B, and C, what patterns do we notice? Well, it should have been pretty apparent that when we evaluated both sides, each and every time, our final answers were equal. Equal and equal. And that's because each time we applied the distributive property. This shows that the two expressions are equivalent for the given values. What would happen if other values were given for the variables? So for example, on C, if instead of 10 we had x equals 13, what would happen to the values on each side? Well, once again, because the two expressions in each part are equivalent, they evaluate to the same number no matter what value is chosen for the variable. So regardless of what number you put in for this variable, they'll always be equivalent when you do all the work. Closing. We're on the home stretch here. How can you use your knowledge of GCF and the distributive property to evaluate expressions? So let's find the missing value that makes the two expressions equivalent. So take a few moments, pause the video, work them out, and come back when you're ready. So really what we've done here is we're just finding the GCF of each one of these expressions. So the GCF of 4x plus 12y is 4. Next one we have 5, followed by 9, then 8, and then 100. And remember what I said earlier, once you use the distributive property, you can actually go back the other way and expand each one of these expressions. So for example, if I take away this 4 here, let me get rid of my 4 for a moment. Actually, you know what? I'm going to leave in the 4, but I want to expand it again. So 4 times x equals 4x. 4 times 3 equals 12, or 12y. So when I expand it, I go right back to where I started. So how can you determine the missing number for each one of these expressions? Well, you'd have to expand each term and then determine the GCF. The GCF is the number that is placed on the blank line for each one of these problems. Great job in today's lesson. Please complete your exit ticket and bring it to me when you're done. Have a great day.